Hello, my name is Pat Doobie, and I teach math at North Shore Community College.
And today we're going to talk about applied percent problems. The best way to explain what I mean by an applied percent problem is to give you an example. In a movie theater, 3% of the customers were wearing hats. If 15 people were wearing hats, how many people were in the theater? One of the ways we solve these problems, the most common way, is we write the problem information as a proportion. And the proportion is always written as amount over base equals percent over 100. We tend to call amount A. So we have A over B equals P over 100. That's how we set these problems up. And we'll talk more about how to find percent, amount, and base in a moment. So for this problem, I've chosen 15 to be the amount. It's the amount of people that are wearing hats. That goes with the 3%. The easiest number in these is to pick out is the 3. That's the P because it's the number with the percent that goes with it. So there's my P right there. Now, once I set up this proportion, 15 is the amount, base is what I'm looking for. P is 3, and the 100 is always there. That just always stays there because 3% means 3 out of 100. That's why we write it that way. What I'm trying to find is this base, B. That's how many total people will be in the theater. 15 goes with the 3, 3% represents 15 people. I would expect to find more than 15 people in the theater if 15 were wearing hats. So I would expect the number B to be a bigger number than 15, and that matches up. The bigger 100 is bigger than 3, so the number on the bottom over here will also be bigger than the number on the top. So let's solve this. We solve these by cross multiplying. Erase what I just did there so you can see the problem. And we're going to solve these by cross multiplying. I multiply 15 times 100, and I get 1,500. And that's going to equal B times 3, which we commonly just write in the other order as 3B. Now, in order to get the B by itself, I have to divide both sides by 3. And I get 500. If I divide 1,500 by 3, I get 500. 3 goes into 15 5 times, and they just keep the zeros. Equals B. So this should be 5. If 15 people were wearing hats, and it's true that 3% of the customers wear hats, then there are 500 people in the theater. That's an example of an applied percent problem. Often in applied percent problems, we are asked to find the base, and other times you're asked to find the amount. This is another example of a problem where we're asked to find the base. This is just like the problem with the hats in the theater. I would like you to pause the video and try this one following the setup of the prior problem. Okay, glad to see you're back. Let's see how you did. So we're going to set this one up as A, amount over base, equals percent number over 100. That's the initial setup of these problems. So I have to identify what I have. Well, the P is the easiest one to find because that's the one that goes with the percent. So I have 30 over 100 on this side. And that's the meaning of the word 30%, 30 out of 100. So 24 red candies are in a bowl, and 30% of the candies are red. How many candies are in the bowl? Well, if only 24 of them are red, there's more candy than just 24 in the bowl. So the smaller number is 24. The smaller number goes on top. That's the amount of red candies, and the base would be the total number of candies. So after you set up your problem, you should check to make sure that if you expect a larger number for your answer, that the variable you're solving for is in the position of the larger number on the other side. B is in the position of the 100. 100's on the bottom. It's bigger than 30, so B will be bigger than 24. That's a good check to do on your work. Again, I multiply, I cross multiply. B times 24 times 100 equals 30B, and I get 2400 equals 30B. In order to isolate the B, I need to divide both sides by 30. Now when I have a 0 on the top and a 0 on the bottom, I can divide top and bottom by 10, and those zeros will reduce. So 240 divided by 3, well 3 goes into 24 8 times, and then I still have the 0 from the 240. You could do that out longhand and check that, but you should have gotten 80 is the amount of candy in the bowl. Okay, so on to the next problem. This one's a little bit different. In the last two problems we solved for the base. Now we have the base and we're asked to solve for the amount. But we set them up the same as far as what form does our proportion take. Here you're buying a new computer that costs $900. That's the price of the computer. But then when you go to pay for it, they're going to add 7% sales tax. How much is the tax? So the proportion setup is amount over base equals P over 100. In this case, the tax is calculated on a cost of $900. $900 is the base. You would not expect the tax to be more than the cost of the computer. 7 over 100, 7 is P. So the price of the computer is $900, that's the base, and the amount of tax goes on top. Now I'm solving this for A. I still do the process by which I cross multiply. A times 100 equals 900 times 7. So I get 100A equals 6,300. 7 times 9 is 63. And then I put the two zeros at the end. Now, whenever I have 100 and 6,300, I can divide this by 10, divide by 10 again. And so I get A equals 63. So the sales tax is $63. Now this is not the amount you have to pay. We'll talk about that in a minute, but that's the amount they're going to add to the cost of the register, $63. Okay, and our next problem is an example of something being on sale. Often sales are billed as being so much percent off. So if you know the original price of a sweater and you know how much percent off it is, you want to figure out how much you're going to save. So sweaters are on sale for 20% off of original price. If the original price of the sweater is $40, how much do you save buying it during the sale? So again, A over B, you're going to be tired of seeing this, equals P over 100. And I have A is what I'm looking for. The base price is 40. The P is the 20%. Again, it goes with the percent symbol. Sometimes that's what is easiest to fill in first. And I solve this. I'm looking for the amount of the discount, not the total price, the amount of the discount. So I multiply 40 times 20, and I get 800 equals 100A. And what you'll notice in all these problems where you're looking for a percent off the whole is you often end up with this 100 times A. You can divide both sides by 100, or you can just cross off zeros on both sides as I showed before, and you get A is 8. Now what does that mean? That does not mean the sweater costs $8. That means that you save $8 by buying it on sale. All right, let's take a look at another example. I want you to try this one. Let's say you make $14 per hour and you're told you're going to get a 6% raise. How much more will you make per hour? I'm not asking for your total cost, just what is the dollar or cent amount of the raise. Try this one and come back and we'll see how you did. Okay, hopefully you figured out how much your raise is, and let's check our work now. I set this up as A over B equals P over 100. Now after a while you're probably not going to write out the form again, but hopefully by saying it over and over you'll remember it. And my P is my percent, so I have 6 over 100. And A over B, well, this is the amount of the raise. 6 represents the amount of the raise, right there. And 6 represents a percent of the raise, and A represents the amount. And they go in the same position in the fractions when you set them up. So B was my base rate, which was 14. I don't need to put the 0.00 for what I'm doing here. So I get 100A. When I cross multiply, equals 6 times 14. 6 times 14 is 84. Hopefully that's what you got when you multiply that out. And now there's no zeros to cross out, but watch this. So A is 84 divided by 100. If I have 100 times A and I just want A, divide by 100. And that, since we're talking about dollars and cents, this means your raise was 84 cents. So in context of money, you want to turn that into dollars and cents. So that's not what you're being paid. You're not being paid 84 cents, but you're being paid 84 cents more. Hopefully you got that one right. And hopefully I'll see you in class.